Daniel Joyeux. Hij is voorzitter, nog maar onlangs in september, voorzitter van de Efectis Group. En hij zal ons toespreken, misschien een stukje over zijn droom, is hoe kunnen we eigenlijk harmonisatie van de fire safety engineering realiseren in de eerste orde op Europees niveau. The floor is yours.
Thank you very much. Good morning, everybody. Just for introducing myself, I will just introduce Efectis as the chairman of Efectis, but I will mainly speak about standardization, but how to use standardization to use state-of-the-art. Because mainly the main problem of the standardization, we are standardized the work that has been made 20 years ago. So it's often very, very difficult to use already within the regulations the state-of-the-art of the knowledge about fire dynamics, fire behaviors of products on systems. So just few words effectively for introduce myself on Efectis. So I'm leading the group Efectis where there is 4 labs. Well, 2 in France, 1 in Turkey, and 1 in the Netherlands. So you imagine that effectively standardization, testing, everything is fully linked. And I will speak about that, on how to link all these things. We are involved for all type of explanation of constructions. It's meant that transportation, industry, nuclear plants, energy sector in general. So we can use all the research knowledge knowledge from all these aspects, because fire safety is really completely transversal and applied on all the type of construction of or industry or transportations. Mainly, as it was during many years ago, regulations are mainly based on the on prescriptive rules, and they were based mainly on the knowledge we have on the fire dynamics occurring effectively more than 20 years ago, 30, 40 years ago, or sometimes, as presenting just before, more than this, on 100 years ago. On 20 years ago, it was relatively easy to change regulations. Now, it's more and more difficult to adapt the regulation to the risk of the building. And it was shown this morning from US point of view about the evolution of the fire dynamics in buildings. So the increased capability of the fire kinetic will need to change to adapt the regulation, but it's more and more difficult for all the ministries that are in charge of the prescriptive rules to adapt it regularly and mainly according to the different investigation we can have. So but these prescriptive rules are easy to define and easy to control. It's why also it's a large impact on it is every time used in each country. But when we want to be outside this regulation, it's often very difficult to justify why you want to not be in line with the regulation. If you have any derogation, the justification is often difficult, and of course it's more difficult for the controllers and for the authorities to justify why they want to change and why they want to increase or decrease the level of the safety that is required by the regulations. So in fact, Europe has been included in the fire safety since the directive of the construction product. In fact, introduced in the end of the 80s, with new international requirements that has been defined, and then all the laboratories work together in order to have an harmonization of the test at the European level. Then we were able to define product performance in the standardization conditions to lead, I would say, recently, because the first products that are required as CE marking was made in 2003. It was the main was the fan for fire reasons, for example. So it's a very recent situation as CE marking on the last products that will be dedicated to CE marking will be the doors. We don't know in few months or perhaps in few years. But nevertheless, this whole European standardization that has been made has been enforced by the CPR. So in 2013, so the construction product regulations. So this was the first step of harmonization in Europe, but we will not, of course, stop at this stage as CPR. And the question is how to harmonize the safety levels in Europe. At the time being, we have, of course, free circulation of products, free circulation of services, free circulation of people. So how to harmonize these safety levels within Europe? And we know that if we want to go comparison between the different codes, such harmonization will be very, very difficult. So mainly there was mainly one way to harmonize the safety level in Europe is to use fire safety engineering in order to satisfy the main essential requirements that are given by the CPR in Europe. So the main question is considering that notion of safety level is very complex to define, and giving a safety level from the prescriptive regulation is today impossible. So making such comparison as prescriptive codes are very, very, very difficult, and I would say impossible. And in that way, of course, because they are often based on different strategies about fire safety. Some are more on passive, some are more on active. Mobile firefighting conditions also are some, of course, are more included in different strategies. On all these prescriptive codes are using all these three combination of strategies for defining their own safety levels. So the main way to harmonize the safety level in Europe is to use fire safety engineering. But today, in the same way, the fire safety engineering as national point of view are open differently. For some countries, it's more free use, and for other countries, it could be controlled or often fully refused to be applied on different constructions. So, how to harmonize the FSC on how to define a new performance-based code as a European point of view, as European level. But before going to harmonization, just using few information on consideration about fire safety engineering. First, if we take the ISO definition from the TC 92 SC4, that was the fire safety engineering standardization as an international point of view, and the last meeting was 2 weeks ago at NIST in Washington. But the main consideration is that the FSC is the use of the tool with scientific appreciation. So scientific, it means that, of course, you need to use the state of the art. You need to use the knowledge that we have today, or not what has been standardized 20 years ago. And mainly the consideration on fire safety engineering is to evaluate analytically. It means that you need to quantify, and it's not only expert judgment. We need absolutely to quantify. Sometimes quantification is modeling, but sometimes also when you don't know, we need, of course, to combine that with possible tests in order to have such information that we can from experimental assessment. But if we go in the scope of application of the fire safety engineering, it means that for everybody it seems clear what is fire safety engineering, but in fact it's often not, because we have also different view about what is fire safety engineering. If we just check about the aim of the use, we have different type of use. For some, it's clearly fire safety engineering is design, because there is a name of engineering in this in fire safety engineering. So it's fully related to design. But for the others, mainly fire safety engineering is verification of performance on behavior of the product, of the system, of the construction globally from the design. So it's two different ways to see the fire safety engineering. And then the main problem we had to use fire safety engineering in many countries is how to make the control of that. What are the different steps of validations? What is the third party for fire safety engineering verification? What is the qualification of the engineers? What is the qualification of the different tools that are used today? But the tools sometimes is very easy to validate. The main problem is how to validate the users that are using these tools. How to standardize the different data. We have seen that effectively for structural engineering, many standardization has been performed. The last years are they always adapted to the current use of constructions or current constructions itself. So there was many questions that can be asked before going to an harmonization in Europe for the use of fire safety engineering. And when we are looking at from the ISO standard, so 23932 for general principle in fire safety engineering, you have different steps to use the fire safety engineering, but I'm just highlighting three of them. The first one is the design scenarios. Design scenarios, if you main application is deterministic applications. So they are defining the end of the fire protections on all the fire design of the building. So if we made any mistake in the fire scenarios, the results will be fully bad, and you will never reach your safety level of your construction. And then you have all the methods, but mainly the first part from the scenarios are more important. And then you have the operation of the building, the life of the building. Are the design scenarios, are the design on the properties of the materials always good, comparing to the life of the building, the evolution of the use of the building. That is always dealt with by the regulation from a part, but as fire safety engineering, it is more complex to use that in order to follow the evolution of the building itself. Fire safety engineering is a huge tool where you need many information in it. First of all, the fire safety engineering is relevant to many different skills that have to work together and interact together. I'm just making a small list, but of course you have more than this. If we are just the ignition of the fire, so more this chemical part about the fire, but also statistics, but also how to take into account arson or not. We'll say that it should be sometimes important to use it. How will the fire will propagate? How the smoke propagation will be within the building? What is the behavior of the fire compartmentations as standardized conditions with the ISO rating? Is it enough or not enough compared to the real fire you can have within your building? The structural behavior, all the egress conditions, the fixed firefighting conditions, but also all the actions of the firefighters, their conditions of firefighting, but also all the strategy may be included in it. So you have all these skills that has to be taken into account when you want to make fire safety engineering. It's why fire safety engineering may remain a result of a team of global knowledge about the behavior of a construction in case of fire. But FSE is often considering as modeling. But we know that we don't know everything. We don't know all the behavior of products, all the behavior of system. But we know also that the fire is something that is very often difficult to model. So FSC needs tests. It's not in the opposite of tests. FSC needs absolutely fire tests, fire behavior of products, of system, or globally as the constructions. They need the standard test, of course, because there is many information within the standard test. There is some R&D test because we know we need to go further and we need to go more in detail the behavior of the different products or any other item within the fire safety of buildings. We need ad hoc tests on mainly for some time for the source of the fire in order to quantify it. We need large-scale tests because small tests and then need try just to extend the result of a small test is often very difficult. So we need absolutely large-scale tests in order to validate effectively extrapolation, but also to validate the model that are used. And we need also in-situ tests in order to verify within the building if effectively all the systems that are installed in the building are the good behavior regards to the design that has been fixed before. FSC needs also to include firefighting conditions, the performance assessment of the intervention. We have different means. The means are in evolution, but we need to be sure that the behavior of the means are relevant to the scenario or the constructions or all the fire load you are within the building. On the example of the quick flashover reached this morning, made from a presentation from US, shows that we need to adapt also our intervention means in order to have the right performance with the right scenarios. But also all the behavior of the product inside the building needs to take into account all the impact we can have on if we need to take into account fire propagation for a big industrial hall where the economical point of view has to be also taken into account on the environmental objectives also. So reducing the fire propagation, we need to use interaction between the firefighters applications and also the fire resistance and fire compartmentations. All these aspects has to be taken into account within fire safety engineering because they are included in the fire safety level of the building. So if we want to make some comparison between the safety level of buildings, we need to take that into account. We need also to include, as European point of view, we know that SFP Europe is working on this aspect as professional recognitions in Europe. So we need to take into account the training, the validations of the tools, the training of the users, the years of experience of all the users, the results of a team, because it's always difficult to have recognition of one guy alone, because that is a very complex system. Fire safety is a complex system with many skills, as we said before. So it's very difficult to qualify one guy, and sometimes it's more a result of a team, so we need to qualify that. Taking into account effectively the independence from the design and the performance assessment, as we considered fire safety engineering may be used in both sides as a design, but also as verifications. So we need to take into account also this differentiation in the user. So how to include what type of control we need to develop as a European situation in Europe. FSC, if we consider that FSC is the state of the art, we need absolutely, FSC needs research. It needs to go on, it needs to go on to learn more about the fire, to learn more about the fire behavior of systems. So additional research are always very important for the future in order to have better tools, in order to have better relationships between the different components of a product or of a constructions. So as, for example, effectively, we work about the combustions on the effluents on the models. We have new products in the buildings, so new materials, so new effluents. We need to quantify all of this, and they have to be regularly quantified in order to be as a state of the art in the fire safety engineering applications. The connections between with the structural behavior, the components between the connections on the between the products, the elements, the protections, all of this has to be taken into account in order to be sure that our model is also taking into account the behavior of the product itself. The comparison between the interaction between fire on smoke propagation on egress models has to be reviewed in the future. All of these data are not so well known today, so research is always needed for that. Fire safety engineering needs also fire investigations to first understand the limits. All this information, even if this sometimes is a disaster, we need to learn about this disaster and make fire investigation to understand effectively the limit of our models, the limits of our fire scenarios, because often the fire scenarios are only based on the past, on very few on the future. So we need to take into account all this fire safety, fire investigation on real fires, and to understand what was from unbelievable scenarios to a possible scenario. This remains also very important, and all this investigation may bring us information in order to define better fire scenarios for the future. And of course, if we are speaking about deterministic scenarios, as I said, there were many scenarios that were completely unbelievable, but now we know that they are possible. Nevertheless, impossible scenarios has to remain impossible scenarios. If we try to design buildings according impossible scenarios, it's really you will never make any design. But if I'm just taking these examples about the big fire, tank fire occurring on a bridge in the entrance of the city of Rouen, where the fire above the bridge, and you have a accident between the tank fire and another truck, and then you have leakage of the fuel under the bridge where there were some caravans, so you were additional big fires under the bridge. So considering that so big fire above and under the bridge was a little bit incredible, unbelievable, but really it was true and this was happening. And this kind of scenarios leads to very big economical loss for the city itself, and not only for one user of a building. It was a complete impact on the economical of the city, on the region. So it's meant that such kind of scenarios are sometimes just to be taken into account, and you need to design if you will take as a design or not, but we need to understand that it's possible. Fire safety engineering needs statistics, and we know that there were many works performed 20 years ago. Now, and then during several years, few works has been made about statistics, and now we are working again about statistics. There were new work as in the ISO TC92 from this technical report 17755. That has been developed last year, and there is different initiatives in this work. And sometimes we need also to learn a lot about this kind of statistics. I'm just giving the recent statistic we made on car fires compared to the statistic we made 20 years ago. And we observed that first about 40% of the fires are arson. So how to take that into account? When the statistic is so high, it's very difficult to say, no, arsons are not within the regulation, we cannot take into account. On where we are looking effectively the evolution of the fire load within the cars, the scenarios that were previously 1 to 7 cars. Now we have some fires with more than 50 cars involved in the car park. So also the fire scenarios is increasing, and you need to take that into account. That is very difficult to take into account within the regulation. So we need to take that into account within fire safety engineering applications. Fire safety engineering needs standardization. Of course, there are different types of buildings where we need some help for the designers, even if when we can make the verification of the assessment, we can go a little bit further in order to be sure that we are not in the limits of the buildings that can reach a kind of level of a disaster. So in that respect, it has been decided 18 months ago to create as a SEN, so European standardization in TC 127, working both fire and buildings, to make a new working groups that I'm the convener in order to deal with fire safety engineering on how to check, how to harmonize fire safety engineering as European level. So this working group, that was previously a task group, so it remained non-official, just discussions, but if we remain at discussion, we never reach any issue for that. So considering that there were lots of development idea within the ISO, and there were lots of initiatives at international point of view, knowing that new European countries need also help for their definition of their regulations, knowing that recently SFP introduced the fire safety engineering certification for Europe. Hotels unions introduce safe hotel classifications based sometimes on fire safety engineering applications. We need then to work about this kind of harmonization in order to reinforce all the work that has been performed, to verify that all these objectives are fully defined previously, and to define our future ourselves for the next design of the buildings. So the main question we have from the working group 8 in order to work on this fire safety engineering applications, the first question is how to satisfy the need of national regulators to develop and provide performance-based codes. Many European countries are far from performance-based codes. There are always a lot involved in prescriptive rules. How to use the current European testing on product standards for having new data in order to understand the behavior of product and system in real fires. So within an FSC approach, on how to satisfy the national safety level and to harmonize this kind of fire safety level as European point of view. So in that case, we define different objectives from the working group 8 as these European levels. Long-term objective is mainly to harmonize the FSC approach as service-free circulations within Europe, and to assist regulators from the EU member states in order to go to the performance-based code. As a mid-term objective, we want to work as producing technical reports for assessing the use of FSC in Europe regard to the different national applications. To make an official link with the ISO TC 92 SC4 for fire safety engineering as international standardizations, and adapt these international standards to European applications. We have seen that as international point of view is very difficult to harmonize, and when each country tried to apply that, because the last applications was being made on the new application that has been made within the ISO with the convener of Daniel Nisson from Sweden, modifications show that it was very difficult to apply this international standard from each country because there is too much national applications. And as short term, we may want to understand the situation in Europe, so we are trying to updating the work that has been made for Benefe 15 years ago in order to check what is the evolution of the fire safety engineering application in Europe since these 15 years. make a review of all the SC4 standardization in order to adapt it to UE, to European Union, to include the recent initiatives within these applications, on work with the other working group from TC 127, so how to work within the XAP on the behavior of products as it is today within the natural file conditions compared to the standardized conditions. We have begun this work about the review of the updating the work of Benefeu made 15 years ago, just to check what is the modification. And we have only 5 responses today, but some are just arriving. So we have the updating of this survey in France, Sweden, UK, Netherlands, and Spain. And we have observed different modification of the situation compared to the 15 years ago. And for example, the main change we have observed is within the education and training. It's meant that before 2000, training on education in FSE was very, very small in many, many countries, European countries. And now lots of updating their education or developing new education as we have in France. And if we check just who is involved in this fire safety engineering training and education, we can observe that for the enforcers and the practitioners, of course, there were some developments. But regards to the regulators, they are not involved in the evolution of that. And this is really missing, and interesting to include that for the future development. So, as a recent work, we try to working on different ISO standards to make this link between the ISO and the CERN in order to take into account the work made as the ISO point of view and not make twice the work, but adapt it to Europe. So, as a global conclusion of all this work we have to make, the harmonization in Europe is a real concrete goal. All the member states in Europe are increasing their FSE each year. On the Benefeu update will be a good observer for that. The member states are voted unanimously as an official working group for European level, so all the countries are involved in that topic. All the states have some experience as FSC application, but very, very different experience. That is really interesting. The working debate has to include all the European initiatives, research, standardizations, investigations. All these aspects has to be included. They have to take into account the international works, because fire safety is known everywhere. And the main topics will be how to develop this performance-based code as a European point of view, but you can understand that long future to reach that, we have many works to do to reach such objectives. Thank you.
Donc, merci bien, Daniel, pour ton exposé. Ik denk samen met u dat die droom nog niet voor morgen is. Cette rêve n'est pas pour demain, si vous. Donc, we hebben ook voor deze spreker nog tijd voor enkele vragen, als die uit het publiek willen komen. Graag. Ja, Ricardo.
You say that at this moment we have enough knowledge to apply FSC to have reliable results, or at least results in real fire safety can apply.
In fact, we will always update our knowledge. So if we are just waiting for new knowledge, we will never apply it. So it's why I consider really fire safety engineering as to be a state-of-the-art application. As we have for a construction of a building, we need to use the state-of-the-art in order to build these constructions. So today we have enough knowledge, effectively, as we can apply what we know. But we just have to know our limits, what we don't know, how to include as a deterministic approach what we don't know, how to include tests when we are not able to make fire modeling where we have some doubts about the results. So we have some limits. We need to know our limits in order to apply for SFT engineering.
Oké. Nog vragen? Oké. Thank you very much. Alvorens wij